everybody, welcome back to my YouTube channel. I hope you guys are doing extremely well. In this video, we will discuss what QLoRA is. Now, before touching upon QLoRA, I just want to briefly discuss about LoRa that we covered in our last video. I know I didn't upload video last week because I was a little burnt out. So I went for a small break, but now I am back again and I don't want you to go back to that video and just to recall what we covered in that. So I am giving you a brief introduction here that what exactly we did in last video. So we started with fine tuning, that why do we feel the need of fine tuning a large language model. So there I gave you an example that, let's say, if you consider a large language model, it's nothing but a next word predictor, right? You have a sentence and it just keeps on predicting the next word that is coming, and it forms the entire paragraph, documents, whatever you call it, right? Now, if you consider chat GPT, it's not just LLM. It has been fine tuned so that it behaves like a chatbot. So fine tuning is nothing but you take a general purpose large language model and you fine tune it so that it behaves specific to your own domain, right? So it performs tasks that are specific to a particular domain. So you fine tune for domain specific tasks. Okay, for example, Chat GPT that is based on LLM, but it has been fine tuned so that it behaves like a chatbot. For example, let's say you ask a question, then it does not directly start with the answer, right? It says, great question, and then it gives you the answer because it has been fine tuned, it has been customized, it has been updated in a way so that it behaves like a chatbot. So this is what fine tuning is. Now there are two ways to do it. The first one is you take your model and you update all the weights and biases that are there in that model. But this is not an efficient technique because uh, large language models are very big in size. They may have billions of parameters occupying hundreds of gigabytes of space. Now, in this scenario, if you just take your data and you start training it, then it will take so many days and a lot of cost related to your hardware is associated with it, right? So that is where parameter efficient fine tuning techniques came into the picture, where you are not updating all the weights, you are just updating a small subset of weights based on the input data that you have. So basically, whatever model you have, you take that model, you free certain parameters of it, and you take only a small subset of parameters. And with the data that you have, basically your domain specific data, then you feed that data into your model, you update those weights or train those weights, and that is what your fine tuned model is. Now, that model becomes efficient enough so that it can handle domain specific tasks. So this is what parameter efficient fine tuning is. And here we covered LoRa. So what exactly you do in LoRa? You take your original model, and you freeze all its weights. And you introduce two small adapter matrices, right? I hope you remember from the last class. So you take your original model, freeze all the parameters, you introduce two new small adapter matrices, and whatever data you have for fine tuning or that is related to your own domain, you perform backpropagation, and the training happens only for this these matrices. Whatever numbers you have in these matrices, only those parameters or weights are updated. This is what LoRa is. Now, there is one problem in this technique, and that is where LoRa came into the picture to s- help us overcome the limitations of LoRa. And that is that it's okay. Now you have reduced the number of parameters that you need in order to train your fine tune model for fine tuning, right? You have reduced the number of weights. Now parameters are way less than the original parameters of LLM. But one problem still exists, and that is you are still loading the original model in your memory. So if your original LLM is of 9 billion parameters, then even if you are not updating any of its weights, still you are loading that original model into the memory, right? In order to do fine tuning, you need to load that entire model into your memory. Now, my computer is definitely not capable of doing it. It will blast. You need a very strong hardware for that. So that is where QLoRA came into the picture. Now, what QLoRA does, in order to understand this, we first need to understand what this Q stands for. So this Q is nothing but quantized. And in order to understand what quantized means, you need to understand what quantization is. So quantization, if I tell you in the most simple terms, it's nothing but reducing the precision. Now you will ask me that what do you mean by that? So let's say I consider one weight of our large language model and it looks something like this. I'm just randomly putting numbers here. 540013. So this is my first weight. And whatever weights and parameters I have in my model, all of those weights have these many numbers or these many number of numbers after the decimal point. Now, the thing is that I can also store this number this way, right? I just round it off to two decimal places, and this also works for me, right? So, what quantization says that instead of storing the model weights and biases in the original precision, you store it in a lower precision format. Now, the benefit is that here you might be saying that the space that this is occupying and the space this is occupying, there wouldn't be much difference. And I agree with you. But just consider the scale when you have billions of parameters and you are just reducing, maybe you are reducing the memory by this much. Okay, or maybe smaller than that. But when you have billions of parameters, when this number is multiplied by billion, then just consider the scale, how much memory you are saving, right? So this is the concept of quantization, where you are storing numbers in a lower precision so that you can save some memory. And because you're losing some precision, but still the model performance is the difference in model performance is not that much. You are losing some precision, but model's performance is still comparable as compare if you compare it with the original model. There is not much difference. So that is the benefit of quantization. And so originally the models are stored in 32 bits or maybe 16 bits, but through quantization we can store them in 8 bits or maybe 4 bits. And I even saw a YouTube thumbnail where they were storing model parameters in 1 bit. So this is what quantization is, where you are reducing the precision and then storing weights and biases. So this frees up a lot of memory, and it then has a very less burden on your computer's hardware. And the LoRa part of QLoRa is exactly the same how we were doing LoRa. The only difference is now we are storing original models, weights and biases at a lower precision. So this is what QLoRa is. You already know LoRa, and now you know what quantized LoRa is. You take your original model and you reduce the precision of weights and biases. Now, before ending up this video, I just want to quickly touch upon what this bit is. So we humans, how we humans write numbers, that let's say I have a number 124, then we use decimal system to get this number, right? decimal system. What this system is, that you take this number, then you take the second number, you multiply it by 10, you take the last number and you multiply it with 1. So whatever numbers we have, we are multiplying it with some power of 10. Okay, and that sum is nothing but at what position the number is. So this is how we humans understand numbers, right? We use decimal system, but computers, they don't store numbers like this, right? They only understand 0 and 1. So that is why they use binary system for storing numbers. Binary system. Now what this system is, that instead of using 10 raised to the power and as we do in decimal system, we a base of 2 use a base of 2. So let's say I have a number 6, then how I would be representing it? 6 will be equal to 2 raised to the power 2 into 1, 2 raised to the power 1 into 1, and 2 raised to the power 0 into 0. So this will be 110. In bits format, this is how you will represent it. Okay. So basically, you store numbers in the form of 0, 1, 0, 1, 1, 0, and you start from the very right and you take 2 raised to the power of 0, then 1, and the number keeps on increasing depending on at what position we are at. And then you just multiply these two numbers together and add them up in order to get the original number back. So this is what bit system is, and in similar fashion we try to store decimal values as well. Method is a little different, but the basic concept is still the same. We use base 2 in binary system, and numbers are only represented in form of 0 and 1. So this is what the concept of bits is. So when I say 32 bits, you can imagine that we have 32 boxes and we are storing 0 1 0 1 0 1 that there. And when I say 8 bits, that means that you have 8 boxes and you are storing 0 1 0 1 in those boxes. So this is what the entire concept of bits is. I hope things are clear. If you still have any kind of doubts, then do let me in the comment section. I would be more than happy to help you out. You can also reach out to me on LinkedIn and Instagram. I'm available there with the same ID that I have on YouTube. So, and I'm happy to announce here that from the next video onwards, I'm starting Fast API series. Yay! So basically, in this series, we will start from the very basics and we will move to the advanced stage where um, I believe that once you will watch the entire playlist, you will be able to build a production grade APIs. So looking forward to it. And if you like the content, then please give this video a like, subscribe to my channel. Thank you so much.